Alright, so today we're talking about the morphine and opioid family related form. So to start with, morphine is the prototype opioid. It's a strong mu receptor agonist due to these three rings, together called the phenylethylamine. So right here is a perfect fit for actually what is actually occurring in the body to the mu receptors. But it's found in poppy plant, but the body produces it itself. And it's a perfect fit for the mu receptors. The mu receptors are dense in the brain, in the postamygdala, thalamus, and hypothalamus, and presynaptic. Um, but the activation slows GABA release, which is the main inhibition neurotransmitter on neurons. There is also a histamine release from the alcohol groups on rings that trigger mass degranulation. So these do make you have allergies, seemingly the side effects. And there's low oral bioavailability because you should not be eating morphine. It's typically injected, and it's named after Morpheus because the first letter of Morpheus in the Greek god name is Mu. In fentanyl, a synthetic phenylpiperidine opioid. So that's the ring with the nitrogen right here in it, and the connected six carbon ring. It's extreme in power, but about 100 times more powerful than morphine, which is why overdose is so common. The piperidine nitrogen anchors receptors and aromatic rings increase van der Waals interactions. So these make for an extreme mu receptor affinity. So this works, but overtly so in human body. This is the natural form you'd think of when you think of morphine is actually occurring in the body. These three carbon rings connected, while this nitrogen in the ring with another carbon ring is what works overtly so. And it's highly lipophilic and rapid penetrating in the central nervous system, so it's straight to the brain. And this is from the lipid loving groups that they have on here. Um, these next two are related in how they're oral, and they both have a methoxy group, which makes it act as it does. So oxycodone, the modified morphine for altered central nervous system penetration. The methoxy groups makes for an increased oral bioavailability, which is great because it's reduced polarity. You don't have to inject it into your arm, so you just eat your medicine in pill form. But you can still see in both of these this six carbon ring is what you call a little bit more natural in form to receptors that they're activating. But encoding is the prodrug of morphine. It's a lot similar to how aspirin is the prodrug of the form it's found in nature, because it suspends the metabolism. But these both need to go demethylation. Um, it has to undergo demethylation to go from codeine to morphine, because in when the body's making morphine, it becomes codeine first. So this is, yeah, like I said, the prodrug version of that. So like oxycodone, the methoxy group methylation blocks interaction in morphine for receptor activation via hydrogen bonding to mu receptors. So it's a lessened effect, but it works. Here we have a tramadol. Tramadol is different in structure, but also in that it's a racemic mixture. So there's the R and the S types, and it's 50-50 racemic. So they have two different interactions with the body. So dimethylamine, so the nitrogen with the carbons. This right here, nitrogen and these carbons. So diethyl. allows for weak mu receptor binding because it is not a typical opioid scaffold like these are. This works overtly so. Fentanyl works overtly so. And morphine, oxycodone, and codeine are more or less the same scaffold shape that work in nature, naturally in the body. So you could think of this as the corrupted version. These two as a slightly different version of what morphine is originally. But tramadol is different in that has monoamine reuptake inhibition. So monoamine would be catecholamines that you noticed as serotonin and norepinephrine, but also dopamine. But um, from the methylphenol, so the phenol group with a carbon off of it is results. There is more serotonin and norepinephrine because it's not being is not getting uptaken. So it's inhibiting the uptake, so it leaves where it is in the brain. And the racemic mixture, like I said, is half of each. So one is for serotonin and one is for norepinephrine, and that's ignored and left there. So one type is what allows for serotonin to stay in norepi from the other. So called reuptake means it stays, and it stays. Will when it stays, it will balance the brain chemistry with these neurotransmitters. So this is what when you think of SSRIs, or this in this case SNRIs, which is very closely related, this makes for a serotonin norepi reuptake inhibitor used for depression treatments. And serotonin is linked to mood, while norepi is linked to alertness. So these have a wide range of different effects, but the shape in organic chemistry in structure makes a big difference in the mechanism of how it works, especially when you think about how these two, especially this one is this. This is the very similar evolution of what becomes morphine. And this is a modified version. And this is the, I guess you could call, very potent otherwise structure to accomplish the same goal. And tramadol is different in how it doesn't scaffold at all. But yeah, thanks.